The question keeps popping up, and I'm glad it is. I'm glad that we're talking about evacuation and how to do it properly. It's great because we've been doing it wrong and we can get better, right? So, the number one thing that everyone always says is if you pull too deep of a vacuum or you pull a vacuum too fast, you're going to freeze the moisture in the pipe. That's kind of true, kind of, very, very kind of. So, by what I mean of it's kind of true is let's think about this. When you lower the pressure on water, you lower the boiling point. So, what do you think's happening when you lower the pressure? You're lowering the freezing point. The only reason the water would freeze is if you have a large amount of water and you rapidly boil that water off because the boiling action is evaporation. And through evaporation, we cool something down. Now, I'm going to show how water can freeze in a vessel such as this one right here, because this right here is Lexan, and I'm going to put water inside that bottle inside this vessel. Now, I want you to understand, do not try to pull a vacuum on such as something like this, because if you try to pull a vacuum on glass like this and you're able to seal it up really good and pull a good vacuum, think about it. For every square inch, you're going to have 14.7 psi per every square inch. So multiply however many square inches is on your container by 14.7, and that's how much weight is pushed on this actual thing, and it will collapse the glass and cause it to shatter. So that's why I will have the glass inside of here, so that way it will not shatter because it's not pressure on the actual glass. The whole inside will be in a vacuum. Now, the reason why the glass will allow the water to freeze is it'll have a rapid evaporation. I'm going to use this tank right here to pull an immediate, like, quick vacuum. No, I will not use this hose because I'm not going to damage my good stuff. For the sake of this, I will use a 1/4 inch hose. This is in a really deep vacuum right now. Flash vacuum this, cause water to freeze, and then I will show the same amount of water inside of this right here and show that you can pull a vacuum. But the thing about this is we have metal. We have precious metals such as copper, aluminum. Our compressors are made of steel, but those are good at absorbing and rejecting heat. That's the whole purpose of air conditioning, is absorbing the heat and rejecting it. So the water or the moisture inside the system will absorb any heat, and you have lowered not only the boiling point, but the freezing point. There has only been one time in my career where I have had water or moisture freeze inside of a system, and that was in Utah in like January, and it was freezing cold outside. I pulled a strainer out of a valve on a roof, and I think it was like 12 degrees outside or something. I got a little bit of snow on it. I was trying to get some metal shavings out of it because it got clogged up on an ammonia facility. Put the strainer back in, pulled a vacuum, and I mean, it was on a section about this big for the strainer because I had an isolation valve on each side. Pulled the vacuum. I caused that little bit of moisture in there to freeze into a little block of ice. That's the only time it's ever happened to me. I'm not saying it can't happen, but in that instance, all I did was I took a little MAP gas torch, heated up the strainer, it boiled off the water, and I was good to go, moved on about my day. So we'll go ahead and show you how you can freeze water, and then I will show you how in something like this, you can still pull a vacuum.